I'm Grant Kohne. I'm a mechatronics student at Channel Islands and a robotics instructor for kids. My students participate in a high school robotics competition where the general goal this year is to grab large triangles and push or launch them over a center bar. I wanted to see if I could take motion sensors and place them on both the robot and the object to see how the motion correlates. This information is very useful to our team because we can quantify how powerful the launcher is and how efficient it is at transmitting energy to the game object. I expect to see equal, large accelerations on both objects at first, and then a sharp negative acceleration on the robot, and a gradual negative acceleration on the object as it launches. This competition lasts the whole school year, and because we are only halfway through the year, this robot is still in its prototyping stage. It's nowhere near done, but we have gotten the robot moving and the launcher launching weekly. So after about 3 hours of soldering, I taped one sensor to the head of the catapult and one sensor to the game object. Both were reading data onto their own microcontrollers. It took well over 5 attempts to get good data because the tape kept falling off and the SD card kept falling out of the board. But once I got it working, I drove to the line, launched the game object, and performed other common maneuvers such as scoring the triangles and spinning. Once I got my data, I then took it back and analyzed it in MATLAB. While there's a lot to look at, I want to focus on the launch. From the robot's perspective, you can see the very sharp upward acceleration followed by an equally sharp deceleration. This is caused by the launcher arm hitting the mechanical stop. Compare that to the triangle, where you can see the triangle has an initial sharp acceleration, but has a gradual rise and fall. The object rotated in the air, which is why it accelerates in so many different directions. Now these are the expected results. Initially, because the launcher and object were connected, they had the same acceleration. But once it let go of the object, it could no longer accelerate by anything other than the force of gravity. Using this data, we can quantify the acceleration of our launcher. As you can see, this catapult launched at approximately 20 meters per second squared. In future iterations, we can quantify how much better or worse we've made this launcher. This is very important to our team because often changes to our robot can seem minuscule or even meaningless. Being able to accurately quantify our improvements can give us concrete results that our building and engineering is working and we're moving towards a better robot.